Platinum is one of the rarest metals on Earth. Only 190 metric tons are mined each year, compared to 3,300 tons of gold. 72% of all platinum is mined in South Africa. Most concentrations of platinum are deep underground, requiring more complicated and expensive mining infrastructure than open surface pit mines. Most metal ores are mined at the surface, but when it comes to platinum, the only large surface mine is the Mogalakwena in South Africa. This mine accounts for 8% of the global platinum supply. 45% of platinum is used in automotive catalytic converters. The main job of a catalytic converter is to allow carbon monoxide to burn with oxygen at a low enough temperature to turn most of it into carbon dioxide, a far less toxic gas. These are generally made of a honeycomb-shaped ceramic and tiny particles of platinum. They also have trace amounts of other metals found as impurities in platinum ore. These metals are called the platinum group metals. The structure of the ceramic is porous, similar to a sponge, which gives it a very high surface area. To somewhat oversimplify, this is important because the arrangement of electrons in the molecules of carbon monoxide allows them to overlap with the electrons in the platinum, attaching without truly bonding. Imagine a door that fits into its door frame but does not lock. It will stay there unless something pushes on it. The high surface area allows oxygen to mix into the tiny open spaces in the ceramic, and while oxygen won't attach to the platinum, it will fully bond to the carbon monoxide, which takes up all of the carbon's free electrons, breaking it off from the platinum. 34% of platinum is used to manufacture higher than high-end jewelry, the largest segment of which is platinum watches. The 4 largest manufacturers of luxury timepieces have all made several series of limited edition platinum watches. The main advantage of a platinum watch is that people will be impressed by you, but they are also extremely durable. Even with only a few hundred of these watches being made each year by all of these manufacturers combined, the metal is so rare that they account for the largest single segment of platinum jewelry. About 9% of the world's platinum is used in oil refineries. This amount varies far more from year to year than the other uses. For gasoline, it is preferable to have all the molecules be long and straight. But with crude petroleum, while some are straight, others are curled onto themselves like rings, and some have other molecules sticking out of them like tree branches. In order to turn crude oil into gasoline, oil refineries need to separate out any harmful impurities and then break up the larger, more complicated molecules into smaller, simpler ones. And the only way to achieve this on a large scale economically is to use platinum as a catalyst. The platinum allows the larger molecules in crude oil to break apart. The simplest use of platinum as a catalyst is as a super thin mesh that holds onto hydrogen atoms. The hydrogen atoms can insert themselves into oil molecules, breaking them apart, almost like a reverse version of a car catalyst. For electronics, platinum is not the most useful platinum group metal. That prize goes to palladium. However, many electronics, especially the processors and circuit boards in computers, require very small amounts of platinum in order to connect the transistors that chips are made from. Platinum is also used in the reflective layer of some types of hard drive disks, but hard drive manufacturers have been making fewer of these types of disks in favor of smaller, less expensive, and more durable alternatives, such as magnetic disks. The electronic devices that platinum is most prevalent in are the expensive spark plugs found in sports cars. Most spark plugs are made from copper, which is cheap enough to be used in large quantities and is the second best electrical conductor, beat only by silver. However, copper is soft and has a low melting point, causing conventional spark plugs to wear down and eventually break. The high temperatures and rotation speeds in sports car engines make copper unsuitable for spark plugs. The traditional solution was to use iridium, an element hard enough and with such a high melting point that it can easily withstand high horsepower engines. Unfortunately for car manufacturers, iridium is even rarer than platinum. The annual global production is only 3 metric tons. There literally is not enough iridium in the world to make all of the engines of expensive sports cars, so manufacturers turned to using platinum, and while platinum spark plugs aren't as durable as iridium ones, they are nearly a quarter the cost, and because of platinum's higher electrical conductivity, they require less material and are easier to make. The final 2% of platinum is used in laboratories. It is used to make containers that can reliably withstand almost any experiment. For example, if you want to make a container that you know will withstand any material at nearly any temperature for any amount of time, without ruining or even staining the container, platinum is the only material you can use. The main use for this is in chemistry labs, where experiments need to be run, one after the other, without contaminating the results with chemicals from the previous round of experiments. For well-funded laboratories, the high cost of a platinum container is usually worth the savings in time. It also eliminates the need to have multiple containers for one experiment. Platinum and the other platinum group metals are in a strange situation in terms of their use. Despite their high cultural status, they are too rare to be used in most luxury items in the way that gold is. But for many of their uses, there is no alternative. For catalytic converters and oil refineries, there are no other materials with the necessary properties that platinum has. And for more consumer-oriented items, mainly watches and car engines, there are other physically similar metals, but all of them are even rarer than platinum. But for electronics, manufacturers are increasingly inventing new devices that don't require platinum. Shrinking use of platinum in electronics and the likelihood of electric vehicles replacing gas-powered ones means that the value of platinum will most likely fall in the future, as it has been doing for over a decade now. On a final note, because of the tiny amounts of platinum used to connect and make some of the circuitry in computers, if you're watching this on a phone, you are looking at the video through a glass touchscreen that has some platinum circuitry in it. Also, the device that I made this video on contains a small amount of the metal, mainly in the hard drive. The total amount is about 0.03 cents for this particular one, or about 1/10,000th of a gram.